Hello friends, today I'm going to solve LeetCode problem number 1129, shortest path with alternating colors. In this problem, we are given an integer n which represents the number of nodes in a directed graph. Each of the node is labeled from 0 to n minus 1. We are also given two arrays, red edges and blue edges. So the element at index I in red edge represents an array which is a length 2, and that would represent that an edge from node A to node B at index I, and the color of the edge would be red. Similar in case of blue, each element would represent a blue edge from node U to node V. Now that we know the problem, we need to return an array answers which is also of length n, where each element in the array represents the shortest path from the node 0 to node x. And we need to keep in mind that the path is such that the edge colors alternate along the path, else we are going to return a -1. Now let's look at this example here. So we are given the value of n equals to 3, which means that there are 3 nodes starting from 0, 1 and 2, and we are given those edges, red edges. Okay, so I'll use a different color here. I'm gonna use black. So an edge is from 0 to 1, which is red. So from 0 to 1 we have an edge red, so it's a directed edge, and from 1 to 2 we have a red edge again, right? So from 1 to 2 the color of the edge is again red. Now there is no blue edge here, right? So we only have red edges. Now what we need to do is we need to find the length of the path from index from like element 0, from node 0 to all the other nodes. So from node 0, what path do we have? So we have a path to node 1, and that's of color red, right? So what the length from 0 to 1 is equals to 1 here. Now what about length from 0 to 0? Well, that would be equals to 0, right? Because we are already at that node. Now what about from 0 to 2? Okay, so from 0 to 2 we need to go through 1. So from 0 to 1 and then 2 we could reach 2, right? But we need to also keep in mind that the edges in the path have alternating color. So the edge here is red, but the edge here also is red. So that would mean that there is no path with alternating color from 0 to 2. So we are going to return -1. What if in case we had an edge here that was of blue color? So in that case we will be able to find a path, shortest path, right? So from 0 to 1 it's a color red, and then 1 to 2 it's a color blue. So we found an alternating path, and the length would be equals to 1 plus 1, that would be equals to 2. So that would be equals to 2 in that case. So basically we need to find the shortest path with alternating colors. Now let's look how we can actually solve this problem. So what we're going to do is we are going to create an adjacency matrix representing all the nodes that we could reach from a given node. And while we create an adjacency matrix, we are also going to store the colors, because we need to know what the color of the node is, of the edge is from a given node to its neighboring node. So that's why we are going to store the color as well. And what we need to find is the shortest path, right? Shortest path to the a to node X. So to find the shortest path, we are going to use breadth first search, because breadth first search gives us the shortest path quicker. So we are going to use BFS, which means that we are going to use a queue. And while we are using queue, we are going to use a visited array to store all the nodes that we have visited, along with the color of the path through which we reached the node, basically the edge connecting the neighbor node. So that is what we are going to use. So we are going to use visited array queue and an adjacency matrix, and we are going to store our result in an answer array. So basically we have an adjacency matrix of which is an array, so there will be four arrays basically. Now let's start coding our solution. So first let us create our adjacency matrix. So it is a equals to new array of length n, and each of the element in this array will be an array itself. So starting from I is less than n, I plus plus adjacency matrix I is equals to new array. All right, now we are going to fill the adjacency matrix. So let red edge of red edges. So from the red edges we are going to fill the adjacency matrix. So red edge index 0, that is from, we are going to push its neighbor which will be at index 1, and the color, so we are going to represent the color red by 0. And similarly we are going to do the same thing for blue edge. Alright, so we are going to represent blue by color 1. Now we have created our adjacency matrix. We are going to create our answer array. So our answer array would be of length n as well. We are going to fill the values by -1, because if we don't find a path, we are going to return -1 by default, right? So that's why we are storing -1 as our default value. Next we are going to create a visited array where we are going to store all the nodes that we have visited and the color of the edge that we visited it from, color between the neighbors. So for let I equals to 0, since there are two colors, so that is why we are going to have visited of length each element of length 2. So I equals to 0 is less than n plus plus visited at index I is an array of of length 2, and we are going to fill all the values by a value false, each of the element in the array by false, because so far we have not visited any edges, right? Now we are going to create our queue. Okay, so our queue will have triplets. So that would be the index that we are starting from, the node that we are starting from, and we are starting from node 0, and then the length so far that we have traveled and since it's the first node, so the length is equals to 0, and the color of the previous node. So since it's the first node, there is no previous node, so that's why we are going to give the value -1. Now we are going to perform our BFS. So while q length, we are going to take the values, that is pop the value first element from the queue. So node length and the previous color equals to queue shift from the queue the first element. All right, and now for each of the neighbor and color of adjacency matrix node. So what are we storing in adjacency matrix? In adjacency matrix, we are storing its neighbor, right, and the color that it represents, right? So we take the neighbor and color, and then we check if the neighbor is not visited, the neighbor with this color has not been visited. Okay, so if visited, it's not visited, and the previous color is not equals to the current color, then we are going to perform our operations in the queue. So what are we going to do is we are actually add the neighbor to the visited list. Okay, let's do, before that, let's add it to the queue. So we are going to add the neighbor to the queue. So we add the neighbor, the length of the neighbor, so that would be the current length +1, and the color of the neighbor, the node, the age that we visited. And then we are going to add our neighbor to the visited list with the color, and that would be equals to true. Okay, so here one thing, since we added this node 0 to our queue, we also need to add it to our visited list. So 0 0 will also be true, and visited index 0 1 will also be true. Why? Because there is no previous node basically, so blue and red both will be true. Okay, we are also going to store the length of the neighbor in our result, because if we found our neighbor at this length, that would be the shortest one, because we are using BFS. So that's why if the answer for the index equals to -1, then we are going to update our result. So answer at index neighbor will be equals to length +1. So why are we checking for this condition here? Because there is a case where we could reach this neighbor in the shortest path where the color is equals to red, the color of the age is equals to red, and in the next case we could reach it when the color is equals to blue. But when we reach that neighbor first, that would be the shortest path. So that is why in that case the value would be -1. So now finally we are going to return our result. Now let's run our code. Okay, all right, so that's answer So one more thing that I missed is answer at index 0 for node 0 will also be equals to 0 from, because the length from 0 to 0 is 0, right? And we need to write that as well. Okay.